Good morning, everyone. Can you hear me fine? Great. Welcome to week 10 session. Hi. This will be our last lecture. And in this lecture, I'm going to talk about the big data mechanism and I'll give you a brief review of the course. Uh, Big data mechanism. So instead of talking about additional big data method, we talked about things like text analysis, association analysis. There's many of them, right? And every day there's new method coming out. So what the problem with this method is that they are developing so fast. Right? Many of them will be outdated in 5 years times. So I thought it's more beneficial for me to discuss the general mechanism behind big data, how it work, how it works. Right? So that reason is gonna stay for longer, and I think it will be helpful for you to master new big data methods in the future, right? And understand how it works. So that's why I decided to talk about mechanism rather than more detailed methods. All these new trends in terms of big data now come from development in technologies. Right? So that advances in technology has changed our way of now looking at the problem and dealing with them. So I summarize the change over here. First, it brings new opportunity and problems, right? Like the problem I gave you in your critical thinking task. So now more and more consumers are using smartphones. So as a business owner, how do you grab that opportunity, right? So think yourself as a local department store. What does that mean to your business? What can you do to grab that opportunity, right? Using analytical tools. So that is your critical thinking job. But this is just a one example that happens to many different cases in the world. And those opportunities are all brought by the advances in technologies. Uh, Secondly, it changed the way we study problem. In the past, classical statistical tools, what you would typically do is that I collect some data, right? I collect a sample of data. Remember the word sample here, right? It's an important word. So basically, you have an entire population. You cannot study the entire population, so you collect a sample of the population, try to using the sample to understand the population. Right? And because the number of data you can collect for this sample is generally small, a couple of hundred or a couple of thousand, but never cover the large proportion of the entire population. So there is a lot of error, right? Data collection bias, measurement, etc. All kinds of error exist in that small sample. So in order to best utilize that sample, you need to clean out the error. You need to understand why. Right? That's why we care about causality so much, because by understanding the logic behind what we observe in this small data set, we are more confident that using this small data, we understand the entire population. Right? So that's a small data world logic, right? Or the classical statistical logic. However, with big data, if you can collect if your sample, right, your sample is the entire population, or no, a large proportion of the population, then causality becomes less important if your goal is to predict. I will talk about it. If you are going to design, etc., reason is still important, and for the long run, it's still important. But for your short-term prediction, all you need is correlation, right? Or whatever data helps you that to improve your prediction power. They are good data, right? You can use them to help you with short-term prediction. So that means now the data source you use, the way you collect the data will change, right? You use it to scan the barcode of all the product you sell, right? But now with now, for example, mobile phone we use, we are sending out the data every second. We are holding our device, right? So the problem is how you collect them and utilize them, right? So the way you do sample is no longer several hundred people. You need to do some random assignment, etc., to ensure the data quality, right? But if you can cover a larger proportion, then it's less issue. Right? Also, because of the amount of data, the way you analyze the data also change, right? And you are going to utilize the result in for example, real time. That means a new way of utilizing the result as well. The mechanism behind the data, many people summarize them as, for example, 3 V's or 4 V's. Now, you can see various versions, but mostly they are talking about volume. That's where big data come from, right? And they also talk about the velocity and the variety. Right? But to me, big data maximum, for the big data maximum to work, there are some additional items. I list 6 of them here, and I like to explain them in this session. First, volume. Right? Volume is huge. Right? You will be amazed how much data has been collected. Right? So this is a chart from 2015, actually, 5 years ago. But even at that time, you can see how many data have been collected. Like a Google, right? Google process 3.5 billion requests per day, right? Even in 2009, they was preparing to have over 1 exabyte of data. What is exabyte, right? And 1 exabyte is about 1,000 petabyte, and 1 petabyte is about 1,000 terabyte, right? Terabyte. So nowadays a typical portable drive, they are 1 terabyte or 2 terabyte, right? So think about 1,000,000 terabyte. That is 1 exabyte. So it's estimated that Google is now at 2015 collect over 10 exabytes of data. I see the amount of them is huge, right? And Amazon even shopping website, right? Shopping website, how much data they collected, right? 1 exabyte of data, right? On average of 1 megabyte per object that they have in their online store. Right? That is a lot, right? For each item, they have 1 megabyte data. So try to get a sense, right? So what does this amount of data mean, right? So let's say this is 10 billion gigabyte of data Google store in 2015, right? So assume we have 3 billion internet users and they all use Google, right? Which is not true. A large proportion do not use it. For example, users from China, they do not use Google, right? But let's say everyone 3 billion you use Google. That means how much per person? Right? That is 3 gigabyte of data per person, right? And if you transfer that into transaction, right? You remember the number record I gave you in the data file, in the team project data file, right? Check how large the data it is, right? Think about this, instead of several megabytes, this data is 3 gigabyte. How many records will it have? It will have about 1 million transaction record. And about yourself, now, can you remember the last 10 transactions you did? It's hard for me. It's hard for me. So every one of us, we cannot even remember the past 10 transactions we made, but Google knows 10 million transactions we have made. All right. So that include those things we buy, include our the keywords you search, right? URL you access, your credit card information, your email, all of this, right? 1 million transaction records. So I think it's at some point it's fair to say that Google knows us better than we do. So why large matters, right? So it puzzles me for some time, because even myself for some time, because large, what does large mean, right? In terms of statistical method, that means no need to sample. Right? That means no sampling error. Because of no sampling error, it allows us to do more. Right? So, for example, there's some noise. Let me mute all other people. Now, if you want to ask me a question, you can turn it on or type in the chat box. Right, thanks. Where were we? So what large means, right? So for example, here's the two examples over here. A classical study will say, in Australia, for example, 35 to 40 years old man, like t-shirt, like blue t-shirt best, right? I'm wearing a blue shirt today. Right? So we have a customer who is 38 years old. It's likely that this person will like blue t-shirt. So let's offer a blue t-shirt to her, right? But big data takes a different approach. It says, no, we feed all the information we have, right? Not about 30 to 40 years, but all information about 38 years old people, men, because we have so many data, right? We got enough information we need. We feed them into the system, right? And then we also know this particular customer's own data. All things about him, and put all this together. Then we can precisely calculate. The system tells us this person, this particular person, has 67% chance to buy our number 3 t-shirt. Right? It's not about the blue t-shirt. It's not about it's our specific number 3 t-shirt. Right. So let's offer that t-shirt to him. So this is a power that the large amount of data gives you. Some more example, right? I like this metaphor a lot. As a quantitative change will eventually lead to qualitative change. As we accumulate enough data, it actually changes the picture. Right? So think about taking photos, right? Those pictures to a movie. Movie, if you know how it's made, right? It's essentially a series of pictures you to play them very quickly. Right? So if you take a picture of a horse, right, you have a stacked view of the horse. But if you take 24 photos per second continuously and play them continuously, then you have the movement of the whole horse. Right? The movement of the horse is some new information that you do not get from a static view of the horse. So that is a good example of quantitative change leads to qualitative change. Because it's a bit hard to understand, I give you more example here. This is Microsoft Grammar Checker. I'm sure many of you know this. So they developed 4 algorithms and feed, they give a try, right? Feed 10 million, 100 million, 1 billion words to each of the 4 algorithms, see how it works. Clearly now, all algorithm improves when you increase your data, right? That's for sure. However, the best algorithm with small amount of data, for example, 10 million, right? The increase rate is only from 86% accuracy to 94%, right? It's still good, but interestingly, the worst algorithm with small data, when you feed in good data, it actually becomes the best algorithm in the big data world. It increased from 75% accuracy to 95% accuracy. Right? So clearly, this best algorithm with small data is more about understanding the logic behind it, understanding the reason, right? But the big data, the best algorithm with big data does not really care about why people say this word, you use this word in such a way. I only care about whether I can predict it right or wrong based on huge amount of 1 billion words, right? So that becomes best algorithm. Another example, quantitative change leads to qualitative change. So another example, Google Translation. I'm not sure if you use Google Translation before. I tried it 5-10 years ago. I also tried it now, and I personally feel the translation accuracy increased a lot. Right? I don't speak other language, but I speak both English and Chinese, so I give it a try. The accuracy improved a lot. There's still room to improve, but improved a lot. It's because algorithms have improved, but also because they feed more and more data to improve it. So they use millions of pages to train their algorithm, which makes their algorithm more and more accurate. They can even translate language which no one in the team speaks. So they also say now the accuracy increase every time a linguistic leaves the team. This of course is a joke, but you need to think about the why this happened, right? So actually, it's not because people leave, accuracy increase. It's because accuracy increase. They no longer need to hire linguistics. Right? Only people from computer science who can write the algorithm is enough. People who understand the language is no longer necessary, right? Because the algorithm is already good enough to make translation. So that's the first feature, big volume. The second feature, I think, is very important to many companies to understand big data, because many companies, they do have a lot of data. For example, a company I worked with, they sit on like 65 millions of transaction record. That's a huge amount of data. The volume is large, but I was not able to help them too much with that data set because that data set is very thin. It's not a rich data set. What do I mean by that? Here's multiple sources, different informations that makes your data rich. Because the data set they have, the 65 million record, they are about the same thing. Right? Every day, who buys, every day, they know what product got sold at what time, at what price. That's it. They don't even know the person who buys it to have any information. They don't have any information on that. Right? They also cannot link other source of information together, which makes the data very long, but very thin, not rich enough for them to act too much on that. Of course, with models I have, I was still able to help them do something, but the power of the method is certainly limited by the richness of the data. So so the second feature I'd like to talk about is use multiple sources of data now to enrich your data set, make it a richer information source. So this also a word, if you heard about it, data fusion, fuse the data together. For example, combining text analysis in your product design, right? So you get, you know how to design air conditioner, right? You have all kind of set of data on one side. Now you have some additional source. Right? That is what people search, the question people search on search engine. And then you extracted the two pieces of information here, for example, using text analysis. Right? So the air from the air conditioner is too cold. Right? Where can I buy air conditioner that do not blow cold air on you? You know, in the summer, we want to use air conditioner, but the air is too cool, right? So that is customer needs. On top of all your knowledge about how to build air conditioner, now you combine customers' needs, fresh needs at the current moment, right? You learn from search engine, then you can make something happen, right? So this is from Haier, right? Air conditioner manufacturer. Right? So based on that, they produce this smart air conditioner. Right? So to address the needs stated above. So the approach is that you see the hole over here, right? So the cold air blow within the hole. So before it blows out, it will mix with the room air. After mixture, it will now increase the temperature a bit, and not directly the cold air on you, but gradually mixing the cold air from the machine and the warm air from the room, and temporarily drop the decrease the temperature in the room. Right? So this is a good example of bringing different sources. Another example, also from Haier. So it's about combining search engine data with sales data, right, to minimize storage. So they found that 5% of people who search air conditioner will buy. And on average, it takes 2.5 days from search to buy. Right? So now you know how many people are searching on internet. You also know your sales data. How can you utilize that to create some profit for you? Right? You know, those white goods, a large proportion of cost come from storage. Right? Because things are too big, right? You need to hire a lot of space to store your product, but you also need to make sure your product is there when customer come to buy it. Otherwise, they would just leave you and buy from another manufacturer, right? So your product needs to be there, but being there takes a lot of storage cost. However, combining these two pieces of information, you can dramatically reduce your storage cost. So this is what Haier did. So they find out how many people search at different locations, different cities, for example. Right? Then they set up the delivery from the manufacturer to the location. Right? The delivery number is 5% times the search number, and delivery time is exactly 2.5 days later at the time of calculation. So in that way, they make their logistics chain a lot more flexible, response timely to the end of the logistic line, which saves them a huge amount of cost. This data fusion sounds complicated, but it does not take rocket science. And here, understanding what's going on, the reason there, and being smart to put pieces together is important. A good example where you both use big data technology, and use your reasoning to understand the why and make it happen. Right? For example, it has been a couple of years ago, right? So when Obama was running for U.S. president, so Paul says, no, Obama needs some help with mid-age female voters, right? And for middle-aged female voters, who do they like? They are crazy for George Clooney, right? So they set up a meeting like this to help Obama among middle-aged female voters, right? And it appears to be successful. Third, velocity. Velocity here most of the time means real-time action. So you get your result, utilize your result in real time. So this is a piece of research that one of my co-authors at MIT did. They worked with a British telecom company. So the question here is, I have different plans to show customer, but the customers have different flavors for the plan. Some want very brief information like this one. Some want very complicated information. They need to know every bit details of the plan. So the question is, which version of plan should I show my customer? And remember now, these are new customer, right? We don't know too much about them yet. Right? We need to quickly predict. At the time they come to our website, we need to predict what kind of web pages they will prefer, will increase their likelihood of purchase. Right? So that is a problem. So they developed this method called website morphing, right? And they developed 8 different versions, like here. They use some click streams. So you go to the website and you click some place, look at a different place. They use these click streams to predict which of the 8 morphs that you like best and offer that morph to you. Apparently, it increased people's intention to buy a lot. Right? As a result, they increased 52 millions in revenue. This is one of the biggest telecom company in UK now, but still this 52 million is a huge amount of money, right? They also did some experiment shows that if they know consumers' cognitive style, so how they process information, what kind of information they need to for them to make a decision. Right? If they know that, then they will be able to further increase another 27 million in revenue. That means more accurate prediction of what customers want to see. So this is an example of React in time. The third V, variety. All kinds of data can help us make decisions. In the past, we only look at numbers, right? But now we look at, for example, taxes, for example, network associations we did last week, right? Here is the example. So there was a big problem in New York because it's a very expensive city, right? More expensive than Sydney. Right? So there's illegal conversion. They cutting up a big room into small cells, then rent out. Right? It creates a higher risk for fire and crime. So they hire some inspectors to handle this case. Right? But now there were only 200 inspectors. And the estimated amount is 25,000 illegal conversions. So how do they handle this? Apparently, they are short of manpower here. So they use all kinds of data and pull them together with a big data model. Right? So including, for example, tax payment, utility usage and payment, type of building, ambulance visit, crime rates, rodent complaints, etc. Right? And they were able to increase the predicted accuracy from 13% to 70%. Why those variables can lead to a better prediction? They don't really know. Frankly, they don't really care. As long as your model can help me predict the illegal conversion 70% right, that's increase my efficiency, right? Efficiency at least 5 times, right? That's good enough. I don't need to know why. Right? Some variable like recent brickwork. Recent brickwork becomes a good predictor for this. Right? But now, for the model, we really don't need to understand why. But usually, when you have a variable that actually works, there's typically some reason behind it, right? So because in the real world, it's still now people do things for a reason. For example, recent brickwork is a good variable because now for those illegal conversions, they don't really care about how their apartment or house look like, right? So they will not bother to do some brickwork. It looks ugly, fine. As long as we can live in there, fine. So as if this house or apartment owner is care enough to bring out recent brickwork, it's less likely that there's illegal conversions in there. Right? So there are actually some reasons behind that, perhaps behind each of them. Right? But when you put together sources, which one is a better predictor, which one is a dominant reason, is there any latent reason behind these variables? There are, but we don't see that in the model and we don't really care. Right? As long as the prediction is accurate. Right? So this is a network example, right? So like Facebook, right? Facebook have know what kind of what friend you have, right? What kind of post you like, and for the same post, now there's some other people who also like this post, right? So here, this is this is a Star Wars Facebook page, right? So green spot, some post, and around some post you can see people connected to that, replied to that post, and easily you can see now there's a few topics and naturally group people into into 5 groups over here, right? Based on their interest in Star Wars post. Right? So then you know your users better, right? Facebook, a few years ago, they increased their number of emoji. It used to be like and love, but now there's haha, wall, sad, angry as well. Right? Why do they do that? Because they can, through that they can understand you better, understand your emotion better. Right? So then they can send the targeting advertisement to you. um, so this is another example of using network to control drug use, because this is a case from US, a small town called Colorado Spring. So they observe the drug users, which is a dot, red dot over here. They have the connections of drug users person to person, because drug is very interesting stuff. If you want to use drug, you need to get drug, right? So you have to connect with other drug dealer or other drug users. And by observing this network, they can find out who is a key person, right? In a sub-network. For example, here, this sub-network, you can see now this person, this person is a one that connected this small network to the rest of the big network. So if you have limited police power and you can only take out a few people out of network in order to control the drug, now this kind of person is the one you need to lock them in the cell, right? They're more likely to be the drug dealer. If you lock them up, then there are other people don't have drugs to buy, and naturally you can better control your drug use. Now, next one is machine learning. Right? We talk about the three V's, but how to actually make things work, right? Make things work. That you need to use the power of latest development in computer science. So we talk about this example at the very beginning, right? So your target knows your daughter is pregnant before you do, right? But how do they do that? Right? After the lecture last week, I hope now you get a sense how they did it, right? So they did some association analysis, right? So people who buy odorless body lotion, switch their pattern. Actually, it's more complicated than the simple example we did last week. So if you observe people switch from their normal body lotion to an odorless body lotion, at the same time they are female at a certain age range, all this information combined will predict, will be associated that later they will buy some baby stuff, right? So that is why Target knows this high school girl was pregnant, and then based on that, they send out catalogs to the girl. Right? So this method was originally used by Walmart. Right? And the one classical case is people like to buy diapers and beer together. Right? Why diapers and beer together? I'm not sure how many of you hear about this, but this becomes a very famous case in business education. Right? Thanks to this business teachers like me. Now many people knows about that. You can guess why people buy diaper and beer together. Right? The thing is that husband like me, right? So my wife say, no, Songting, go out and buy some diapers, right? So then I go and buy some diapers. Then I feel, no, I'm doing something good for my family, right? So I should reward myself as well. So on the way to get some diaper, I buy some beer together, beer for myself. Apparently, that was actually the reason why people buy diaper and beer together. But machine learning, like association analysis, right? So they find out that association. They don't understand why, they don't really care. But based on that, you can put diapers and beer together to make it easier for people like me to buy diaper and pick up beer together. Well, sometimes I initially didn't think about buy some beer, but because they are together so close, it's kind of remind myself, right? It's kind of shouting to me, hey, Songting, you did something good. You deserve some beer. So buy some beer together. Things like that. And thanks to business school teachers, now your friend also know, right? So your baby shower becomes like that, right? Baby product and beer as well. They also find out that when hurricane comes, people need to buy some product related to hurricane. Right? This time you're combining the weather information with your sales record. Right? So now you know when the hurricane comes, what kind of product customer needs to buy. So you can put them at the front of your store easily for people to pick up. Right? Apparently, it's called a Pop-Tart. Pop-Tart. Pop-Tart is quite American style food, very sugary, very sweet stuff. It's a breakfast snack, right? So for whatever reason, I don't know for sure. When hurricane comes, people like to buy Pop-Tart. They even know which flavor people like most. Right? You can guess which one they like best. is this the strawberry one. Strawberry is the one they like best. So the machine learning is on the computer side, how to make it work, right? But on the other hand, you still need to combine different data sources together. How do you know they are from the same person, right? That we need to talk about the digital footprint, right? So wherever you browse, you use your smartphone, you're sending out your identity. Right. So using this identity, people can combine different things you do, now merge those data sources together. So for example, this is at some stage I was searching for this memory card for my digital camera. So I went to office work and search for this SanDisk 32 gigabyte memory card. Right. 1 second later, on another website, I did an experiment. Right? I close office work, then the next second I go to another website I frequently visit, because English is my second language. I try to make sure that my pronunciation is correct. So I use this website called howjsay.com. They have a lot of advertisement. It's if you speak English as a second language, I think it's a fairly good website. But one thing is that it has too many advertisements. And just 1 second ago, I searched this. 1 second later, I see the items I searched on this website. I think they use the cookie in my internet browser to deliver that information to this howjsay.com website. So they find out, oh, it's the same person who just searched a 32 gigabyte memory card. So I should offer him all the advertisement to relate to that. Right? So it's here. It's here as well. On top of this golden one, I have silver one as well. Silver one here, silver one here. Somehow they also find out people who search this one will also have a higher likelihood to buy some other stuff, like this Bluetooth earpiece, like a mouse. Maybe at some earlier stage, I even searched these items. I just don't remember myself, but they still remember it, right? So they show this to me again. So I was thinking, wow, that's quick. And how much was my identity leaked, right? So if I use a different browser, what will happen? So I used IE, Internet Explorer, which I never use, which I never use on my computer. So when I use IE, all these ads about the memory card disappear. At the same time, I visit the same website, but all these advertisements based on my search result disappear. But somehow they still get some of my information, because you can see here now the big data definition. Big data definition. I can hardly imagine a typical internet user. Now 99% of people will search for big data definition. Right? It must be some of my computer use makes they think that this may interest me, which is indeed correct. Right? So my conclusion was that when I changed different browser, my personal information was not leaked that much. But anyway, some part of it has already leaked as well. I guess nowadays it's very hard to avoid that. So this is your real footprint mapped based on your smartphone use. So you may get amazed. So like a Google Map, right? You can show they can show how traffic is going on in front of you. right? So then you can better plan your route. It's very convenient for you, but how do they know? How do they know there's a lot of people over there and how fast they move? Because they are all using Android smartphones, right? So believe me, when you start to use Android phones, there's a long list of agreement which we have to agree in order to use, and no one actually reads. Somewhere in that long list, you have already consent for Google to use your data footprints over here. Right. So as long as you use an Android phone, even if you do not turn on your Google Map, you're still giving away your location information. And this is not just about Google, right? Other smartphones like Apple users, don't laugh, you give out your information as well. Windows phone users, as long as you are using smartphone, most likely you are giving out your information real time. All right. So this is a map of one person's footprint, right? And for example, every 1 minute or even 10 seconds, we have collect a data point, right? And based on data point, you can infer a lot of things, right? So for example, this person spent a lot of time in this area. This is Melbourne, by the way, right? This person perhaps walked along this road, right? Even without machine learning, if use my naked eye, I can find that out, right? And here you see why there's such long way over here and some stop over here. But most likely this person took bus or drive a car. There's some traffic stops over here. So this person drive a car or take a bus over here, maybe parked somewhere, start to spend some time over here, go along this street. So, I can infer a lot of information with my naked eye. So this digital footprint is very useful. At some stage, I will not be surprised if I walk by advertisement post and it's the advertisement over there is tailored based on my preference. That's completely possible, and I can see that happening even in a few years. So these features all make our big data work. Or the big data that leads to the change in how we find out new opportunities, create new solutions, how to collect data, how to utilize, implement solutions. All these are affected. All right, so before we move on, let's take a 5 minutes break. Then we will come back and talk about the can and cannot of big data. Let's do a 5 minutes break. All right, let's come back to lecture. All right. So I just talked about the mechanisms that make big data work. Now I'd like to talk about the can and cannot of big data. So big data is good at knowing what is. Where you have a lot of data, right? If something has already happened and you have already collected data, well, they're very good. Right? But they are not good at knowing what is not. Right? So if things did not happen, right? Or in your statistical models, those insignificant results, where it perhaps should happen but didn't happen, which is also informative. Right? But big data does not know that, because if the things has not happened, there's no data. No data means you don't know. You don't know. Another thing is that they know example about what is not, like new customers and new product, new ideas, new environmental context. Then big data don't know what's going on. right? Because it never happened. Right? Also, big data is good at knowing what is going on, but not why. Now that we have talked about a lot. So they only care about the prediction accuracy, only care about the correlation, right? But not the reason behind this. Because of that, in time-wise, big data is good for short-term prediction. However, in the long-term prediction, you can see it will be hard for big data. Well, actually, it will be hard for both, but the understanding of why gives you a better leverage to predict, to look a little bit further than a very short-term goal. So that is two major things. Example. This is actually big data, both success and failure. I'm not sure if you know this. Google tries to predict the flu virus spread using the search terms. It was a huge success in 2009. So they basically, based on people's search engine keywords, they were able to predict where, how fast the flu will spread. It's as accurate as the CDC, the Center for Disease Control. I'm sure nowadays you perhaps heard that a lot. It was good at that time. As accurate as them, but much faster. The CDC was like 1 or 2 weeks later, but Google was real time. It was very good. However, when flu happens again in 2013, the Google tried to predict again, but actually they failed this time. They predicted 10.6% of visits to doctors, but the actual number was only 4.5%. Why? 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 So because a new context happened, because of their success in 2009, people now know Google is very useful to predict the flu spread. So many people go to Google and use Google to find out how flu is spreading, which makes now unexpected high volume of searching on Google. And now as a result, they mistakenly predict too high volume of flu spread. Right? So new situation happens. The big data they have not have those data in their data set, right? So they don't know what has not been observed. All right. So this is why cross-selling. That is one important concept in marketing. So you can see the data says now 70% of customers who buy A also buy B. Right? And there are other 30% people who buy A but did not buy B. Right? So there's a different approach. Different method will tell you. With big data, they will tell you, hey, now 70% is a large confidence, right? So let's promote product B to other 30% customer as well. But by saying that, think about it. You are making some assumption. Right? You're assuming that all these other 30% people who also want to buy B, it's just because they didn't see it or some other reason. That's why promotion to B makes it work. However, a classical approach will try to understand why those 30% people didn't buy. Right? If they are not aware of product B, then you should promote it to this 30% of customers. Well, if there are two segments, they're just another segment of 30% people, then promoting B to this customer just won't work. All right? So understanding why helps you make your decision actually better. Make your decision process better. So big data, this is a joke written about big data, right? So this is largely about the mechanism, machine learning mechanism used for dealing with big data problem. So this is like a pile of algorithms, right? So this person says, is this your machine learning system? Yeah, you pour data into this end, then into this big pile of linear algebra, then collect the answer over there. Right? And this person, what if the answer are wrong? Then just stir the pie until they start looking right. Right? Because this is a big black box. You don't really know what's exactly in there. Even the person who built this model don't know why the details of how this model works. It's called interpretability. Why things works, because a weakness of big data model. So big data looks fancy, but it's not the solution for every problem. It suits a certain type of problems. At the same time, many other problems needs a thorough understanding of why. In those cases, those classical methods should be used. And here is an example. Traditional research method shines. So this, I'm not sure if you heard about this product. It's a famous product called Viagra. It's a deal with erectile dysfunction treatment. So that the product itself was a very, very interesting case as well. It's not related to big data, but the repositioning of the product. So the Viagra was initially designed to treat hypertension, that is high blood pressure. Then they find this side effect. so the main effect is to treat hypertension, right? But they find this side effect which can be used to treat erectile dysfunction. Then they smartly reposition the product from hypertension to erectile dysfunction. Apparently, this side effect treatment is much more profitable than its main purpose. So it was a huge success. But now, then there's a similar product that come out, new product, just a few years, right? Come out at the market called Cialis. Cialis. Well, similarly they treat erectile dysfunction, but as a new product, they come to research questions, say, a managerial problem. How should I position myself to compete with Viagra? Right? So they did some research. You know, Viagra position, the positioning of the product is to for men, right? All of their advertisement is about men themselves. I will show you two commercials in the next slides. But now everything about the Viagra advertisement is about men, now make you look more man, right? So that is what Viagra are about. But Cialis, right? They took a different approach. They study the market. So, oh, well, there's a man market, but there's another market called the we market, right? Because this takes two lovers participants, right? So no, you're only focusing on one end, but what about a couple? Is there any market in the we market rather than me market or man market? Right? So they did research, and how do they find out this idea? Right? You cannot get that idea based on existing data, because existing data, they're all from men, right? So the product users, buyers, the doctor who see their patients, they're all dealing with man problem. Right? They will not tell you something else. But this Eli Lilly company, when they do research, they study the women as well. Right? And they discovered that this we market is actually twice as large as a me market. So it was a huge success. Just in a few years, in this erectile dysfunction treatment market, Cialis becomes a market leader. Right? Although Viagra has been there for a long time. Right? So you can I have two interesting commercials for you. First, let's look at this Cialis commercial.
Cialis Tadalafil for daily use helps you be ready anytime the moment's right. You can be more confident in your ability to be ready. And the same Cialis is the only daily ED tablet approved to treat ED and symptoms of BPH, like needing to go frequently or urgently. Tell your doctor about all your medical conditions and medications and ask if your heart is healthy enough for sexual activity. Do not take Cialis if you take nitrates for chest pain, as this may cause an unsafe drop in blood pressure. Do not drink alcohol in excess with Cialis. Side effects may include headache, upset stomach, delayed backache, or muscle ache. To avoid long-term injury, seek immediate medical help for an erection lasting more than 4 hours. If you have any sudden decrease or loss in hearing or vision, or if you have any allergic reactions such as rash, hives, swelling of the lips, tongue, or throat, or difficulty breathing or swallowing, stop taking Cialis and get medical help right away. Ask your doctor about Cialis for daily use and a 30-tablet free trial.
See, now Cialis commercial is always about a couple, right? It's always a we in the in the advertisement. But comparatively, Viagra commercial is always about men. Let me show you another one. So this is not a direct Viagra commercial, right? So you guys know this Ellen DeGeneres show, right? So this is Ellen's show about a new Viagra commercial where they, for the first time forever, they used a women spokesperson in their advertisement. But you can see it's still about men.
Saw a lot of commercials and learned some interesting things. Number one, Pizza Hut is willing to shove anything into its crust. Number two, every other commercial is for Cialis.
So in this show, she makes fun of both Cialis commercial and Viagra commercial, but you can see how she jokes about it and sees a different position of these two brands.
The thing about the Cialis commercials is they show couples doing activities together and the husband gets in the mood. Doing, some of the activities are normal. Tennis, you see the tennis, and then he hits her on her butt, it's the beginning of knowing he's in the mood when it goes. Then there's random activities like, have you seen the painting the bench? They're pretending to paint a bench. There's nothing on the brush. And he's really turned on by that. Take a look.
You make a great team. It's been that way since the day you met. But your erectile dysfunction, it could be a question of blood flow. Cialis Tadalafil for daily use helps you be ready anytime the moment's right. You can be more confident in your ability to be ready.
If that turns him on, what doesn't? Actually, I can't tell if seeing his wife painting a bench gets him excited, or he needs to take Cialis, or if he already took it and the Cialis is kicking in at the wrong time. And then the new, have you seen the Viagra commercial? They hired a woman for the first time. They have a woman spokesperson, and she is very, very blunt.
So guys, it's just you and your honey. Setting is perfect. But then erectile dysfunction happens again. You know what? Plenty of guys have this issue, not just getting an erection, but keeping it. Well, Viagra helps guys with ED get and keep an erection. And you only take it when you need it. Ask your doctor if Viagra is right for you.
So she's British. She can make anything sound classy, but I'm not sure if I mentioned this before, but Viagra originally asked me to do the commercial and be their spokesperson. And I did it, and I thought it went well, but I guess they decided to go with her. But here's the commercial that I made for them.
Hello, men. It's me, Ellen Listen, I'll be honest with you. I don't have an accent. And when it comes to your downstairs area, I don't know how any of it works. And frankly, I don't care. But I know when you can't wake up Sleepy Joe, it's a nightmare. It's nothing to be ashamed of. Plenty of men can't get their noodles al dente. So, if your soldier won't salute, then Viagra is for you. Sure, there's lots of problems in the world, crime, the economy, global warming, but this is important. We need to fix your... All you need is one of these little blue pills. I fell off the bed. But I have to warn you, if you have dizziness, difficulty sleeping, or if your cobra remains charmed for more than 4 hours, please see a doctor. So if you think Viagra is right for you, talk to your doctor or your healthcare provider. Just don't talk to me about it. Yucky.
So from this show you can, of course, it's interesting to work. Now from this show you can also get a sense how women women will view the Viagra position of their product, right? And from that attitude, I can see that this we market is perhaps a lot larger than me market, right? So this is where traditional research shines, because now as a product who all your data gather is about men. Frankly, you will not be able to find that in your data. So there was a time. So on the internet, no one knows your dog. So this is one famous cartoon made on the New York collection. I think it's perhaps the most, somewhere I learned this is highest cited cartoon made. But then there's some follow-up. So nowadays, of course, they know your dog, your shopping pattern gives that away. So with big data, we learn a lot about customer. But there's something behind this. Do people actually know your dog based on your shopping pattern? Not really. Frankly, they don't care if you're dog, if you're cat. As long as they predict that you're going to buy dog food next time, they will show you dog food, right? They don't know who actually you are, and they don't care. Even the people who run the model, they perhaps don't know why they are recommending dog food to you either, because machine did it all. So as a matter of fact, for example, in this cartoon, if another user you use this computer, then your thought that this user is a dog simply is not accurate, right? So in the long run, understanding why, understanding who are actually using the computer, how the different people, different human or dog can use this computer, understanding that reason will, in the long run, will help you do your business, do your marketing. But in the short run, when you have a good amount of data, you have capable analytical knowledge and skills to deal with this data, then big data is a good tool. So here I quote, what is big data's current place? So although this is written in 2013, I think it's still true. They say it's a tool that doesn't offer ultimate answers, just good enough ones to help us now until better methods and hence better answers come along. We must use this tool with generous degree of humility and humanity. I think that's good to say. Big data are great tools, right? But in order to make good use of this, they need to have good masters who know how to fight the war. Right? So another example here. Today I have showed a lot of examples. Right? Another one about big data is a movie that I think it's an interesting movie. You can take a look. Right? It's called Brexit, the Uncivil War. Right? So in this movie, one key fact is that they find that these 3 million people using social media. Right? These people will say yes for leaving, for British to leave EU, right? But they never vote. All right. So in the movie, they highlight the fact that social media was used to find out these 3 million people, encourage them to vote, then make the leaving happen. Right? Well, that is about the power of big data. I agree. However, it largely missed the master of this weapon. You need to know. You need to know that there's a bunch of people, right, who will say yes for leave, but they never vote. You need to know the social media is a way to get there. You need to know how to send a message that can encourage these people to say yes in the voting. All right? And those big data cannot help you do that because brick accident only happened once. There's no data for that. You need to understand why, understand the reason behind all this to make it happen. Right? And then another example, this is a message. I like this a lot. So originally, this is their slogan. Originally, the slogan was vote, leave, take control. Right? So this is a core message they want to send. But then this smart guy, right? Then this smart guy and say, well, I need to revise this slogan to make it more powerful, right? Because I understand what people feel, right? So I adding take back control, which makes this slogan a lot more powerful among the people that they're targeting. Because adding back makes people think, hey, no, those control were ours originally. It's just it was taken because British joined EU, and I want to take that control back. I get a sense of ownership, right? A sense of entitlement, and because of that sense of entitlement and the sense of ownership, I should go there and vote yes for leaving. Right? That makes the message a lot more powerful. But such kind of idea you will never, well, perhaps I should never say never, but very hard to get from machine learning method, big data, because no data exists. You cannot afford to do experiment over here, right? With no data, your data enabled method cannot tell you. Right? So you still need to use your smart brain to understand why and to create solutions creatively. All right, so that is about big data. I hope first you get excited about big data. At the same time, you will also have better understanding of what big data can do and cannot do. All right. So for those who are interested in this type marketing analytics career, I would recommend that you not only now look at big data, perhaps as a first step, you need to be a good master of the traditional classical method, because that trains your analytical thinking a lot. Then you expand your skill set to embrace the power that new tools that can bring you, because they are indeed good tools. in some of the field, right? And indeed very powerful. Right? But no, still they need you to understand thoroughly what they can do and cannot do, what their pros and cons, how you best utilize those results. All these things are important. Right? As a human being, our participation in this data in this marketing analytics game is still critical. All right, so let's have, in the end, have a brief review of the entire course. All right. Marketing analytics, all right, it enables companies to do things that they were not able to do well in the past. Right? That includes know your customer's secret even before they themselves do, right? And based on that, being able to do more activities, then support your decision making through marketing decision support system. Right? All these, the marketing analytics can help you. And the expectation for the contemporary marketing analytics is higher and higher. Right? We are looking at understand the customer needs deeper at the individual level, dynamic nature. Then we can take personal activity, take personalized actions for each individual. Right? We can do that in real time, and all the decisions we make is not now just the light bulbs, but all evidence-based, right? That means scientific decision making, right? And those results can be optimized by analyzing your input and output, finding the optimal level for the for your marketing target. Right? So here is this expectation become higher and higher. The reality is there's some leading companies that dominate the big data technology. They're very fancy companies, only a few of them. But the majority of the companies still don't know where to go. The top level managers are eager to embrace the digital age. The middle managers, they are still not sure where to go, how to get there, and the operational level stuff is simply not trained to do that. Right? And that means a lot of opportunity for you. Right? If you can do this job, meet these expectations, right, by having a good understanding of both marketing and analytics, then you have huge opportunity over here. All right. And this course intends to start to prepare you on that career path. All right. So I hope you have get an overview of the marketing analytics. Right? You get a chance to design an analytical study and implement those tools to get some insights. Right? Then translate those results into managerial insights can actually be implemented to help managers. Right? Then you also communicate those findings and work in teams to get the result. I hope that you have experienced all this in this course, and hope you find it inspired to start your marketing analytics journey. All right. In terms of the topics and the models we learned in this course, now the first one was regression, right? Well, logically speaking, you will find many things that essentially regression, right? Because they're all about how I change one side of thing, the IVs, independent variables, will lead to the change in the other side of the equation, which is the dependent variable. Right? All we try to do here is set up this relationship, and you can see that logic virtually applies to almost every method. Right? Almost every method. Right? So knowing the logic of regression is very, very important. Right? And we first utilize this logic regression tool to understand the consumer preferences. including using their survey or transaction data to find out their preference, or a conjoint study, where we also use a regression to find out pathways, right? Pathways is also about how people like each of the feature levels, right? So then based on that, we can optimize our product design, optimize, for example, how much we should sell the coffee bean, right? All this we can get, all those are the insights we can get from those regressions. And the logics of using this all this data to understand the people's preference is nicely pictured by these, right? So we need to understand the people's purchase procedure, how they make decisions, and then utilize different stages in this decision. We can get some measure, right? For example, perceptual measure, it's about their intention, right? Behavior measure about what they do. If you happen to be a B2B business case, you can even objectively calculate those value, right? So all these measures at a different stage can help get a sense, can help us understand their preference, help us understand why they buy. Right? Model. Now here I want to say a few additional words about the model, typical regression, right? So a model simplifies the real world problem. It picks out the key information from here. Right? For example, in this picture, right? This picture, what is interesting in there? Well, it's can you find some animal in there? It's a bit hard because the color makes all this noisy, right? But I need a few lines to circle this. Now this could be a very simple model. And with these a few lines outlining this, it's much easier for us to find this lizard over here. Right? Lizard is a useful information here. And with the help of a simple model, we can discover that. The model is trying to remove all the other noise over here and find the key insights. In a regression model, now we are ignoring all these errors, right? The errors are all the noise over here, and the key regression equation is key insights. Is a model. So a few lines we draw here, right? The key information we try to find. A model, in order to for us to achieve that purpose, right, should make things as simple as possible, but not simpler. Right? So this is a nice saying. Actually, when I searched it, the ownership of this saying was not a definitive. Apparently, many people may have said that, but typically people will say, no, Albert Einstein said that because he's one of the most famous, his most famous one. So if he was the one said that, it makes this more powerful. So and anyway, this saying is great. No, let's assume Albert Einstein said that. So finding insights, rely on wisdom. That's another comment I'd like to make. Because we all see the same result, but whether we can draw useful insights from there is a question mark. For example, insignificant result. Right. So here is a story about Sherlock Holmes. Right. So it's from the story Silver Blaze, the dog that didn't bark, right? So this other detective, Gregory, says, is there any other point to which you would wish to draw my attention? Then Holmes said, no, to the curious incidents of the dog in the nighttime. Then Gregory says, no, the dog did nothing in the nighttime. Holmes said, no, that was a curious incident. That did nothing was exactly the interesting point. Right? So why did Homer say that? Because if there's some stranger, the dog should do something, should bark, right? But the dog didn't do anything. Well, that actually leads to is a very helpful information and leads to very useful knowledge here. Right? Again, when you see an insignificant result, many people just throw it away, right? It's insignificant. We don't know if it's different from zero or not. But it can possibly miss out some information. If maybe you have a variable that should be significant, right? They didn't see that significance. What does that mean? Maybe there's something wrong with your data collection. Maybe it means there's several segments that exist in your population. You should separate them instead of modeling in the current way. These are all very useful information. Right? So you cannot simply drop an insignificant result. You need to be smart, understand why in order to capture the useful information. Then we talk about, we first talk about what kind of value customer wants, right? And then we also talk about what kind of value can customers bring to a firm, right? We calculate the customer lifetime value, right? It includes economical value, which part can be calculated, and some relationship value, right? Which so far we are not able to quantify them very well, right? But when you are able to quantify this value in some way, then you can also calculate it. Now you can use the same way we calculate the customer lifetime value to calculate the relationship value as well. Right? So if we can do that, it will lead to a better calculation of customer lifetime value. Then we talk about after we deal with customers, customer values, right? In the first session, we deal with values. After we do that, we start with the strategy part, right? And one base for marketing strategy is you treat customers, you see customer difference and utilize that heterogeneity, right? So we talk about segmentation, right? Segmentation based on people's needs. That's needs-based segment. Right. So base variables help us understand the customer's needs, how that is different across different customers, and the descriptors helps us to find out who the customers are in each segment, and if I want to find them and target them, how to do that. All right. So and we also introduce this cluster analysis. Right? Hierarchical cluster analysis help us get an initial understanding of the how people should be grouped. Right? Then some more precise method. After we understand how many clusters we want to classify, right? So then we can use this PAM method to get a more precise classification. This is an example, right, of you using this needs-based segment concept to classify people into 4 segments based on people's heterogeneous needs over there, right? And we talk about when we are at different locations on this GE portfolio map. Right? So on one hand is your competitive strengths. On the other hand is market attractiveness. Right? When you identify people, different segments, it does not mean you can just go wherever segment you want to go. That is not right, because you need to examine yourself as well. Do I have a good match between my firm and the segment I want to go in? Right? So you may find, for example, the new PDA market, the consumer, this tech, the innovator, right? Those who want high-tech very much. You may find this segment very attractive. But look, you are a company who are good at making industrial level PDA. Now, then you perhaps there lies a very high risk for you to enter consumer this first segment. Right? I'm not saying you're not able to do that, but it takes a longer way for you to get in there. You perhaps need to redesign your product, redesign your distribution system, redesign your entire marketing team to go there. Right? Perhaps you want to start a new company to deal with that. Right? And now you may have different competitors in that segment as well. So analyzing all these, you need to think about your strengths and the market attractiveness. And when your target segment is located in different areas, now you may have different marketing strategies to deal with that. Then we talk about the market response models, right? We spend one session on how to deal with price curve, this demand, the demand curve, right? Demand versus price. Then we also spend time on this ad budget model, right? How your marketing expenditures, like in advertisement, leads to a sales level change. Both of them, you can see them as a market response model, because the logic here is the same. It's all about you putting some input. You have different product, price, advertising, sales effort as input. Then this model can help you predict what kind of output will be. Right? Then utilize that model output. You can you can optimize your solution, optimize your input in order to get the best outcome. Right? So that way, this market response model system, that actually marketing decision-making support system, right? Decision support system. And we talk about the 3 goals people have for marketing analytics, right? The last one is to build up marketing decision support system to help you make decision. And the market response model is such kind of system here, right? So the loop close, right? In details, we talk about the demand curve and elasticity. We also talk about the ad budget model. And these are different directions, right? Demand curve will decrease as your market variable price increase. Right? On the other hand, this ad budget response function, when you market the input variable increase, they should increase. So these 2 models, they deal with these 2 directions. Right? One is going down, one is going up. But like the input, like advertisement, sales force, now all these marketing variables could lead to demand increase. The ad budget model is very useful for most of them. So basically, we talk about 2 types of model to deal with marketing strategies response. Such a market response model, once we get it, we can simulate market reactions. Right? When we change price, what will happen? When we change our advertisement input, what will happen? Right? Then we can optimize our marketing strategies, help us allocate resources across different marketing activities. Right? This side effect, which is also very important, is that such a market response model system will encourage a systematic thinking among the team and easily build consensus. Right? If you ever worked in a company for real, you will know getting consensus, persuading people is a big job, right? A big job to do. Making sure people are on the same page is sometimes a very difficult job. But if you can set up such a model system, because it's very hard to argue with model, argue with data, right? That's where the empirical result is very powerful. Right? No one argues with them, so you can easily help you build your team consensus a lot easier. Then we talk about some latest development, including some online advertising. We focused on pay-per-click analysis, which is mainstream advertising new version of advertising nowadays. We also talk about association analysis, market basket analysis, and text analytics, which helps us deal with different types of data. And today we talk about the mechanisms for big data to work. We identified the 6 elements over here. Well, that is pretty much all from this course. So before I conclude and wish you good luck, can you let me know if you have any questions or comments? Any final discussion you would like to make? No, of course, I will have consultations this week and next week as well. So if you still have a question or things you want to discuss with me, happy to. So if you don't have any question, thank you. If you don't have a question, let me wish you good luck with your final exams and best wishes for your future career. And remember now, even after you leave this course in the future, now if you want to discuss with me in terms of marketing analytics, you are welcome to do so. As a matter of fact, just a few weeks ago, I have a former student who now get a job. They are running a startup company. They were puzzled by allocating advertisement resources across different advertising channels, and he come back and to discuss with me. It was pleasant to see that they are using the things they learned from this course. As a teacher, you know. It's actually a delightful experience to see that the thing I teach is actually used. That's great, and you're also welcome to do so in the future. All right. So that will be all for this course. Thank you again, and I wish you all the best.